Okay, so for most of you, you don't have to look at the first few questions on here because I had already done them in class with you. But for period 5A, for some reason, I just lagged a little behind. So I'm going to go over the questions from in class, and you can finish them on your own. We went over the question about getting the equation of the line passing through the 2 points. I remember doing that. And I think we were up to the question where we had to get the equation of the line parallel passing through the point. I'll just start there. So we had this question. All right, get the equation. This was the second question on the handout from in class. Get the equation of the line parallel. That's the symbol for parallel. To y equals negative 1/3 x minus 2 passing through 4 negative 1. So in order to get this equation, you look at the word parallel. Parallel means same slope, right? Parallel means same slope. So therefore, this is the symbol for therefore. I'll be using it all year. Therefore, the slope is negative 1/3. Now you write the point slope formula. Y minus y1 is m times x minus x1. We take this point here. The 4 is going to go in for x1. The negative 1 is going to go in for y1. And we already have our slope. So we get y minus negative 1. So as I told you, even though I'm going to say minus negative 1, I'm going to write plus 1, because minus and negative is plus a positive, and then we have x minus 4. We're done. You can just leave it like that. If you want to distribute and bring the 1 over, feel free, just in case anyone wants to see that. That's a 4. You would distribute and bring the negative 1 over, which would give you y equals negative 1/3 x plus 1/3. All right, so that was the second question. The third question was get the equation of the line perpendicular. Upside down T is the symbol for perpendicular, and perpendicular just means that they form right angles at their intersection. Perpendicular to 3x minus 4y equals 8, passing through negative 2, 3. Okay, so number one, we have to get y alone. So I'm going to subtract the 3x. So you want to be in the habit of writing the x first. It's just good habits. Okay, every subject area has certain things that you want to have nailed down as just good habits. Okay, even sports, right? So since it's perpendicular, I have to take my slope, I have to flip it, and I have to change the sign. That's what it means to be an opposite signed reciprocal. So my perpendicular slope is negative 4/3. So let me just move this page down a little. Alrighty then. I will continue this now. So now I get my equation, y minus y1, m times x minus x1. So this negative 2 is going to be my x1. But when I have x minus negative 2, I just write x plus 2. This 3 is going to be my y1. And as we agreed upon, that is our slope. Okay, so the last question that we had in the class practice asked us to get the equation of the line perpendicular to y equals negative 2. Okay, keep in mind, Vux Hoy, y equals negative 2 is horizontal, guys. So if we want something perpendicular, it's going to be vertical. So we already know our answer is going to be vertical. So it's going to be x equals something. So we have this equation and we want it to pass through to -3. Well, if it's passing through to -3 and it's vertical, the only way that can happen is if x is always 2. All right, so now we're going to move on to the next lesson. So the rest of you could have fast forwarded through that. So the lesson we're going to be doing is on a directed line segment, partitioning directed line segment. It's one of the more popular topics. So I'm just going to jump right in. First, I'm going to give you the formula. Hold on, that's messy. Messy. So I have x sub 1 plus a over a plus b. I know none of this has any meaning to you right now. x2 minus x1, y1 plus a over a plus b, y2 minus y1. All right, so this is the formula for partitioning a directed line segment. So here's an example. Find point J on the directed line segment AM. So by directed, it means start at A and go to M, such that the ratio of AJ to JM is 1 to 1. Okay, this number is A, this number is B. If AM has coordinates A, -3, 4, and M, 1, -2. So the way you're going to do this is where you're starting at is x1, y1, so we're starting at A. Where you're ending at is x2, y2. Then it's just a matter of plugging into the formula. So I have x1, which is -3, plus a over a plus b. Well, a is 1. A plus b would be 1 plus 1, or 2. And then I have x2. Well, x2 is 1 minus -3. Then for my y value, I have y1 plus a over a plus b, y2 minus y1. Okay, from there, you're just going to do the math, guys, and get the answers. You're going to have -3 plus a half times 4, -3 plus 2, so that's -1. Over here, you're going to have 4 plus a half of -6, so that's going to be 4 plus -3, or 1. So this would be your answer. There are other ways to do these problems, but this year I'm choosing to do it this way because I'm trying to keep things as straightforward as possible during these times, okay? Stress-free. So that's the formula. All right. Now, by the way, when you have a ratio of 1 to 1, it means one piece is the same size as the other piece. So we also call this special partitioning, we call this a midpoint. There is another formula that you can use when you have a 1 to 1 ratio, or you see the word midpoint or center. And that formula is that you average the x's together and average the y's together. So if I take my x values, -3 and 1, and average them, I end up getting -1, like I already got above. If I take the y values and average them, I end up getting 2 over 2, or just 1. So you get the same answer. It is a specific example, or a more specified example of our partitioning a directed line segment. So midpoint is a 1 to 1 partition. Okay, if you were to take this original formula up at the top and manipulate it, since this formula is always going to have 1/2, right? Just to show something to you, for those of you that are interested in higher math, the a over a plus b is always going to be 1/2 here. So if I just take this part, I'm just going to show you that this part here is equal to this part here. And then you could do the other part if you wished, okay, depending on your interest level. So if I take this expression here and distribute the 1/2, I get 1/2 x2, right, minus 1/2 x1. But do you see that these are like terms? Well, don't they combine to 1/2 x1 plus 1/2 x2? Wouldn't that just be half of the sum of x1 and x2? There you go. So that is a proof that this formula here is just a shortened version of the partition formula. Okay, so you're probably going to want to pause this, make sure you get this all down. Now I'm going to do another example. Find point L on MN such that ML to LN is in a 2-to-1 ratio. Okay, so keep in mind this is A, this is B, A plus B is 2 plus 1 or 3. So A over A plus B is 2 over 3. So that just means that the point L has to be 2/3 of the way along so that you end up with this split of 2-to-1. Which makes sense because you'd have 2 pieces, right, out of 3. So you'd end up with 2 pieces to 1 piece. So think of it that way. So here we go. I'm just going to use the formula. Oh, I have to give you the points. That would help. If MN has coordinates M1, -1, and N, 4, -7. Okay, so since I'm starting at M, that means this is X1, Y1. I'm ending at N, so this is X2, Y2. You can practice writing out the formula if you wish. Doesn't matter how much time has passed, okay? This has always been a good strategy. Writing something over and over and over again, it does sink in your head. Even if you don't want it to, people. So just keep that in mind, okay? Write this formula enough, guys. You'll never forget it. So I have 1 plus 2/3. Remember, I already did this up here. X2 minus X1. Then for my Y value, I have -1 plus 2/3 Y2 minus -1. Okay, remember, I'm a big fat liar. Minus -1. I'm just going to write +1. So here I have 1 plus 2/3 times 3. Now you could do this mentally, do it in a calculator, whatever you want. Over here I have -1 plus 2/3 times -6. Okay, so that's going to be -1 plus -4. And that's 3, -5. So what this means is that the point L, if you were to make this line segment and graph this, you would see that the point L splits the segment so that you have 2 pieces to 1 piece. Okay, so this first section from N to L is going to be twice the length as the section from L to N. That's what's going on here. Okay, so probably going to pause this, right? And you're going to make sure you get this all down. One more example. If the center of a circle is -2, 3, and one endpoint has coordinates 4, 1. Find the other endpoint. And one endpoint, I should say, of a diameter, so that you realize you're going across the circle. Find the other endpoint of the diameter. So what's happening here is you have some circle. Okay, the center is -2, 3. I'm just guessing where it is. So that's your center. And then one endpoint is at 4, 1. Okay, and so you want to have some diameter. So we're looking to find that point on that end. So the center of a circle is the same thing as the midpoint of the segment, right? So we can just write the formula x1 plus x2 over 2. That's going to equal -2, because that's the coordinates of the center, right? The x coordinate. y1 plus y2 over 2 equals 3. Well, now I'm going to put in this point for x2, y2. Doesn't matter what you put in for. You can put in for either. So I have y1 plus 1 over 2. I'm going to cross multiply here. Cross multiply, cross multiply. Get 6, get -4. And then you just have a simple algebra problem. So you get x1 is -8, y1 is 5. Therefore, the coordinates of this point are -8, 5. All right, guys, that's a wrap on the second lesson. So make sure you take good notes.